Hi guys, when you first get your sludge, what you want to do is give it the once over. And by that I mean you want to first get a good look at it. So just turn it around in your hands and see if you can identify anything by sight. You're not going to be 100% sure of what you have, but you might get some ideas. For example, looking at this sludge, I can tell that I have at least 2 solids that I can easily see in here, possibly 3. I've got this metallic looking thing on top here. I've got what looks like a white circular crystal there, and I've got what looks like another solid that's sort of brownish there. And I can make some guesses about these. You know, that metal could be any shiny metal, really. Based on the thinness of the strips and the fact that they look really bendable, they could be aluminum or magnesium or maybe even zinc. All of those are metals that bend easily. And I can see that it's probably not copper, whatever that metal is, because the copper has a very distinctive color. It could be iron, but to know that I would have to grab a magnet. Iron will actually respond to a magnet right through glass, so I could tell easily if I just go grab a magnet if this is magnetic or not. And as to the solids down here on the bottom, based on this picture, you know, maybe if I was looking at it live it would be different, but based on this picture I'm not 100% sure whether that's 1 or 2 solids, whether that's a trick of the light that makes that white stuff on top look like something different, or what the deal is. But what I want to do once I've kind of come up with those basic hypotheses is start to investigate. So I'm going to want to separate the solids from the liquids. Hopefully it's obvious to you how you might do that. And then after I get them separated, I should run some tests. Start with the liquid. Let's see if we can find the density of that liquid. You should know how to do that. Try not to lose any of the liquid because you're not going to get more, so you want to be really careful that you lose as little as possible during transfer and so forth. And that density will not tell me the identity of anything because I know I have at least 2 liquids. So 2 liquids mixed together will give me a density somewhere between the densities of the 2 liquids I have. But that'll give me sort of a hint about what 2 liquids might be in there. And then I can also test flammability of those liquids. A good way to test for flammability of a liquid is to get a glass stirring rod and to sort of protect the glass stirring rod from breakage because they're not really good at being put in a flame. You can sort of cover it with a small piece of tissue paper. I recommend tissue paper over paper towel just because it's a much lighter piece of paper and it tends to burn better. Grab that piece of tissue paper and just wrap it around the tip like I have here and then dip it in your liquid. Have a beaker of water nearby because if it is flammable, you want to be able to put it out easily. You can see in this picture on the right that whatever liquid I dipped this in was in fact flammable. As soon as I ran it through the flame and pulled it away, the entire thing continued to burn. You want to put it out right after you notice the flammability factor because I don't want you breaking my glass stirring rods. So they break really easily when they're overheated, which is part of the reason why I'm having you wrap it in tissue paper. Knowing that you have a flammable liquid or that you don't will help you identify your liquids, but it'll also help you know how cautious you have to be when and if you decide to heat these liquids. If you're going to be heating a liquid that you know has at least one flammable component, you want to keep that in mind as you work through your different procedures so that you're really careful with it and you don't let it get near a flame unnecessarily. And when you are heating it, you're heating it in a protected way that prevents fumes from catching fire above it. The next thing that you can test is the solubility of the solids that you have. You can probably guess that if you do have a metal in there that metal's probably not going to dissolve, but you could test that out. Just take a piece of it and drop it in some water. You could also try dropping it in alcohol and also in hydrochloric acid to see how it reacts. For the acid testing, you'll have to come see me. But I want to point out when you're testing for solubility of a solid, you want to use really, really tiny amounts of both liquid and solid. So what I would recommend doing is use your flask and get some ethanol from the box in the back of the room, and use your beaker and get some water from the sink. Get 2 pipettes, you should have 2 already, 1 for each container, and then use your small test tubes, which you can see here, to run your tests. So you can put a little drop of alcohol in one test tube and a little drop of water in the other. Make sure you don't mix them up because they look alike. And then what I recommend doing is use your pipette as a measuring tool. Just mark off how high up the liquid is in your pipette so that you know that that's how high up it has to go in the other pipette. Don't use the same pipette for these 2 tests because you'll cross-contaminate them and that'll mess up your solubility measurement. This is how it should look when you look into the test tube. You're going to drop about this many grains of solid in there. That's all you need for this amount of water. And you're going to drop it in, and you want to look at the test tube from all angles. This is actually the bottom of the test tube. I took this picture by having a student actually hold the test tube above the camera, and then I took a snapshot of it. Looking at the bottom of the test tube will show you much more clearly what has or has not dissolved. And I gave this a good stir with a scupula for a while before I assumed that it was in fact not dissolving, because it does take time for stuff to dissolve. So this little solubility test will help you know if the solids that you're able to see are in fact soluble in one or both of these liquids. And then if you want to do an acid test, see me and we'll set that up for you. When you're testing with hydrochloric acid, it's usually a good idea to create one of these little gas traps. You don't have to do it in the hood, but if it's available, we might. I'll bring the acid over. You're going to need a small test tube, and you're going to need one of these little plastic tubs and a clamp, and you can just sort of clamp it in place. I gave you a large clamp, but you can go get a small clamp. And then once you have the gas trap set up, I can actually hook up my acid set up to it, and then you can watch to see if there's any reaction in here, and if there is, you'll usually get a gas in here, hydrogen gas, which is very, very explosive, and you can do a little splint test to verify that that's what you have. Some other tests that you can do real quick on your solids is you can test oxidation, melting, and spectra, which are all sort of related to each other. These are all responses to burner flame. So your metal might melt, it might oxidize, which means react with oxygen from the air, or it might give off a particular color of light when it's put in a flame. I've created I've created a device for doing some quick testing, and you'll see it. It's kind of ridiculous looking. It has this little spongy green box here. This is actually a paper clip that I did here. And I created it so that you can use it two ways. You can stick a piece of metal in between the two pieces of paper clip there, and then just hold the whole thing by the green end in a flame, and this will help you see what happens when you put your metal in a flame. It might oxidize, meaning it might turn a different color, or it might burn actually, and give off a flame of its own, or it might give off a color that's of interest to you, and it could, in theory, it could melt, and any of those things would be useful information. So you can do that. Be careful when you're doing it. Don't waste too much of your sample, because remember, you want to run a lot of tests later. This is just preliminary work, and you want to save as much of your sample for after it's all separated. Then let's say you have a powdery type substance like down here. You can use this rounded part to get some on the tip. So the way that you do that is you just dip it in some water so that it will stick. So you can see that the white stuff stuck to this because I wet it first. And then you can put that in the flame. If it's a soluble substance, you might even get a spectra analysis. You might be able to see if color in your flame from that. And if it's a non-soluble solid, you might find that it melts or that it oxidizes, or any number of things could happen. So you're looking for all three of these things at once when you do this test. So by now you should be used to archiving, but I want to remind you that it's really important that you get pictures, because the pictures are what help you remember what you did. So that you don't have to sit there and write everything down as you're working, you can do the writing part later if you get the pictures. So there's a couple of different ways to get pictures. If your iPad is not camera enabled, you can borrow mine. You can go get your cell phone and use your cell phone, but don't wait. Don't stand around going, oh, I'll deal with the pictures later, or I'll get pictures from somebody else. Get some pictures. Be aggressive about it. You really want pictures of yourselves running these tests and collecting data. And that way, when you go home tonight, you can take 5 minutes and just write down everything that you learned by doing this. In your archive, you want to write down not only what you did, but what you think it means. And I strongly recommend that you find some way of highlighting evidence in your archive. So if you come across a piece of evidence that makes you think, oh, hey, I definitely know I have this now because of this piece of evidence, find a technique to highlight that in your archive. Maybe it's as simple as you're going to highlight words that indicate evidence in yellow, like you're just going to, do something like this over the top of anything that's a piece of evidence, or maybe you circle it or anything like that, because later when you're done collecting data and you're done with the experiment and you have to fill out the sheet that I'm going to grade, you want to be able to go through your archive quickly and pull out the pieces of evidence that you've gathered. So you want to be able to have some kind of highlighting system in your archive so that it's easy for you to do that. I also recommend that after the first day's sort of preliminary testing, that you recreate your flowchart around anything that you've learned. So instead of having just basic generic terms in your flowchart, for the next day, for day 2, for your block period, you're going to want a flowchart that indicates anything that you're sure you have in your starting box. Also, don't forget when you're doing your sludge that you want to save time for cleanup, and that you want to be paying attention to the not only how you clean up, but how organized you are with your lab setup, because I am going to be grading you on adherence to safety rules, your ability to clean up on time and well. The lab station should look when you're done the way it looked when you showed up. As I go around the room towards the end of the period, I'm going to be looking for people that have failed to clean up their lab station adequately. I'm going to be looking for missing items from your lab station. I'm going to be looking for things that you put that are there that are dirty or that are wet and that shouldn't be. You need to keep things neat and organized for the next group, because it's really, really important that every class that I have the same opportunity to be successful during the lab. Another little piece of advice, somewhere along the line during your testing, you're going to need to do fractional crystallization, because you're probably going to have either 2 soluble solids in your liquid, or maybe even 3 soluble solids in your liquid, or even if you don't know that. So you want to assume that you do have at least 2 solids that are both dissolvable in some liquid, probably water. So when you're doing fractional crystallization in a lab like this, unlike when we did it in class, you really don't know what you have, and you're probably likely to have a very small amount of it. So for example, when I did my practice test, this is what I found. I got this out of my liquids. After my liquids were taken care of, this is the solid that was left behind that had been dissolved. And then that wasn't very much. There wasn't a lot there. It was something like 3 grams, I think. And that's really a tiny amount of solid, so I'm going to need a very small amount of water to dissolve it. And since I know that they both dissolve in water, because one of my liquids was water, I'm going to assume that I'm going to need just a tiny amount of hot liquid to get my more soluble when hot solid to dissolve, right? Because think about it. What you're doing is this. When you fractionally crystallize something, let me just move my title down here so I have room to draw. Okay, look, this is what you're doing. You're increasing the temperature this way, right? And as you do that, the 2 things that dissolve respond differently. One of them needs to change its solubility significantly as you heat it up, and the other one needs to stay roughly the same as you heat it up. And that way, if you do your dissolving at this temperature, at this high temperature over here, 70, 80, 90 degrees, that way you should find that all of this one dissolves and this one stays mostly undissolved. But if you use too much water, they're both going to dissolve, right? So what you want to do is you want to use a tiny amount of water. And since you're going to use a tiny amount of water, 1 or 2 milliliters of hot water, it's probably not a good idea to filter it, because when you filter the water through a piece of filter paper, the filter paper is going to absorb some of that water, which messes the whole thing up if you have a tiny amount of water. So what you want to do instead, I think, is use this little technique that I've perfected. You can use this little weighing dish as the spot where you're going to do your fractional crystallization. Heat up some water, just a small amount, get it up there till you're 80 or 90 degrees, and then use a small pipette to pipette a milliliter or 2 out. Don't go all the way up into the bulb, because you'll burn yourself if you try and pipette hot water out of here all the way up into the pipette's bulb. You'll burn your fingers, right? But pipette enough out that that you feel like that's going to dissolve the more soluble one, but not the other. And you're guessing, right? You don't actually know. So you might as well, less is more in this case, right? Start slow and see what you get. So then you can take that hot water and pipette it in to your tray. And you can see, if you look closely, that it looks like some of my solid has dissolved and some has stayed on the bottom, which is exactly what I want. The more soluble at high temperature one has dissolved. So that solid is now in that liquid. So I need to get that liquid away from the stuff in the bottom of the tray. Probably the best way to do that is to just re-pipette it up. Take this pipette and suck up the liquid that you just put in there, take it back up, and then pipette it into an evaporating dish. Now on the bottom of that tray, you should have your this solid, the one that doesn't dissolve very well at high temperatures, will be in your tray, and the one that does dissolve at high temperatures will be dissolved in your liquid in your evaporating dish. And you can boil that liquid away very easily in that evaporating dish. And in theory, you now have one solid in here and one in here, and that's the goal of the whole thing. So that's a really good technique for fractionally crystallizing a tiny amount of solid. Last but not least, also, at some point during this lab, you're going to need to fractionally distill your liquids because you have at least two. So when you do this, you're going to use, instead of a probe, you're going to use a real thermometer. That's just because I only have 6 probes and there's more lab groups than that. So I'm giving you a boiling point apparatus that has a thermometer stuck through it. And you're going to need to have test tubes set up over here for collecting your different fractions. You don't know how many liquids you have, so a good thing to do is just boil the whole thing and watch for plateaus, and then redo it and separate them. I recommend that, in the beginning, I told you, make sure, test to see if you have a flammable liquid. Because if you do, you want to keep that in mind. You're still going to do your distillation this way, but you want to keep in mind that if you have a flammable liquid, if fumes start escaping out the sides of your test tube, which can happen through no fault of your own, it's possible that your flame could jump up and catch them on fire. And then you get this very dramatic looking flame up here. But if that happens, you just need to back away from it, let it do its thing. It'll burn itself out. You can call me over and I'll check into it. But just be mindful of the fact that that could easily happen with your flammable liquid. You definitely want a water bath, especially if you have a flammable liquid, because you don't want the fumes of that flammable liquid to escape. So that cold water around your test tube will encourage it to stay here and not come back up into the air and get over where the flame can ignite it. Watch out for your tube getting into your flame because it will melt. And make sure that you have plenty of alcohol because it can take a while to totally distill something. Again, I recommend that you just heat it up and watch for plateaus. You're not going to have data collection from your probe because you got a regular thermometer, so you got to keep your eye on it and maybe get a stopwatch on your iPad and record, every minute or so, check to see if the temperature has changed, or maybe every 30 seconds. What you want to do is figure out what liquids you have based on how many different boiling points you get. So like, let's say that you see that you get a nice plateau at, I'm going to say, 50 degrees. Well, that might indicate that you have acetone. And then you get another plateau at 70 degrees. Well, that might mean that you have, a different liquid. And then you get another plateau at 90 degrees. That could be 3 different liquids, and you could identify them that way. And the next thing you would want to do is separate them so you can find the densities of each of those liquids. Okay, so that is it for your sludge suggestions and tips. If you need any help, remember that when you ask me a question, I'll let you know whether or not I can answer it with or without point deductions. But if it touches on safety, chances are it's going to be a freebie. I will always want to hear from you if you have questions about safety. If you have questions about exactly how much of something to use or when to use it, if I think that it's safe either way, I might say to you, well, that'll cost you a point if you want me to tell you. But, you want to ration how many times you ask for my help. Remember that the people around you may have similar looking sludges, but they are all slightly different. So you don't want to necessarily base what you do on what you see them do, because that could really lead you down the wrong path sometimes. Okay, guys, I'll see you in class. Good luck on your sludge test.